All right, guys, how we doing today? So we're going to do a quick focus review, what we left off with last week, which is finding these exact values, sine, cosine, and tangent, given specific angles of rotation inside the unit circle. I don't have the unit circle drawn here, but we're going to kind of hypothesize through it. So first thing we need to do is we need to draw this angle of rotation. So this is negative 3 pi over 4. So that's in radians. Let's put that thing in degrees so we can make a little bit more sense of it. So we've got negative 3 pi over 4, and we are going to multiply that by the conversion factor, pi over 180, so we can get these pi's to go away. So we get negative 3 times 180, that's negative 540. We're going to divide all that by 4. Tells me that this is negative 135 degrees. Now the reason I say we want to put all these things in degrees is, man, we've dealt with degrees forever. Radian is only something we first talked about back in Math 3, so it's going to have been something relatively new. This is a whole lot easier to draw angles of rotation with. So 135. So negative means that we are turning clockwise direction this time. We always start on the positive x. And we're going to go more than 90. We're in fact going to go 45 more than 90, which is going to become important. So that puts us right over here. So that angle of rotation, that's our negative 135 degrees. So we drew the angle of rotation, check. Now we want to find the reference angle. Now remember, what we want is, there's a point out here that's going to have a coordinate. That coordinate's what we're going to use to find sine, cosine, and tangent, because we have a unit circle here. I just don't have the unit circle drawn on this picture. Now the reference angle, these lines from this dot always go back to the x-axis to make triangles. It makes a right angle right here. So the lengths of the sides of this triangle are going to give us these 2 points, 2 coordinates down here, and that's what we're going to use. Reference angle is this angle in here. Now, we knew this went back negative 135. We know that this is negative 90. So we know that this right here, this distance in here, that's 45. And the way that we turned it was negative. But reference angles are always going to be positive because they're inside the triangle. This is the angle that we need, and if that's 90 in here between, this is negative 180 if we're going that direction, that means this thing has to be 45. So what happens is that this is a special right triangle that has a 45-degree angle in there at the vertex. So let's draw that thing. We'll make it look like the one right there. You see we're taking this triangle right here, we're pulling it out, we're going to make it bigger so we can label those. So our right angle is right here. And we just figured out this was 45 degrees. So therefore this also has to be 45 degrees. And since we were inside the unit circle when we did this, we know that this length right here is 1. This is a special right triangle. That's what we were really talking about with these exact values of sine, cosine, and tangent. This special right triangle, 45, 45, 90s, inside the unit circle with a hypotenuse of 1, have sides length root 2 over 2. And what that means is that this distance right here, from here to this spot, that's negative root 2 over 2 because we're traveling backwards on the axis. So that gives us our x-coordinate, negative root 2 over 2. Then this thing goes down. Down on the coordinate plane is negative. So this is our length right here that goes down. That means this also has to be negative root 2 over 2. So there's the x-coordinate, there's the y, and what we learned is that the x tells us cosine of our angle of rotation. Y tells us the sine of our angle of rotation, and y over x is how we found is what tangent of that angle equals. So let's go up here, label these things, and write down our answers. So let's do cosine, sine, and tangent. So cosine is the x, and the x is negative root 2 over 2. Sine is the y, and that's also negative root 2 over 2. Anything with 45-degree reference angle is going to give you these root 2's over 2's. You're going to get the same number. You have to check which quadrant you're in to determine which one's positive, which one's negative. All right, tangent. So tangent, we got to take these two things and divide them. So let's actually write this down here. That's going to be root 2 over 2, negative root 2 over 2, divided by negative root 2 over 2. Those two things are exactly the same, so they cancel, and so do the negatives. All we end up with is 1 over 1, so tangent at this spot is 1. Oh, and I didn't label these correctly. Let me fix that. These shouldn't say theta. We know what theta is. Our angle of rotation was negative 3 pi over 4. And this is something you could plug into your calculator and you could check. If you hit, now you have to make sure your calculator's in radians, and plugged in tangent of negative 3 pi over 4, you would get 1. Sine, you would get this. Now you get the decimal equivalent of this, which if you go through and you do the decimal equivalent of this, which isn't what I wanted for this activity, you're going to get negative 0.707, about that. There's going to be more decimals, but that's really what it is, and you can match those things up. All right, let's try another one. 300 degrees. No need to convert. Positive rotation. So 300 degrees. So let's label our axes. So this is 90, because we start here at 0. This is 180. This is 270, and then all the way back here is 360, because we can continue to rotate and rotate, but we don't need to because we only need 300. So we know 300 takes us over here, and it's actually going to be a little bit closer to this negative y-axis because we're only 30 degrees past 270. So this is our angle of rotation, 300 degrees. Now remember the triangle that we want, because we want to find the coordinates out here. We always go and drop this line back to the x-axis. We want those lengths here. This is our hypotenuse and our adjacent. I know I kind of left that out. We did it real fast up there. And in here we're going to say this is 1 because we're in the unit circle. So that length right here is 1. Anyways, let's go back on that because we're going to need that space for something else. We know that we are 30 degrees past this thing. 300 is 30 degrees past this, meaning that this reference angle right in here that we want has to be 60. So our triangle, where we want to draw this, let me get this oriented correctly for us. There we go. Our right angle was right here. Our 60 degrees in this corner, leaving only 30 degrees down here. Our hypotenuse was 1. This is a 30, 60, 90. So one of these sides is 1/2, one of them is root 3 over 2. Now this is the way I remember this. 1/2 as a decimal is exactly equal to 0.5. Root 3 over 2 is about equal to 0.866. Which one of those numbers is bigger? That one is. This one is bigger or longer. So therefore, if you draw this setup close to scale, the longer side should have the root 3 over 2. Now, the way I always remember this as well, whatever side is opposite the 60 has to be the bigger side. So that's going to be our root 3 over 2. Smaller side is what was on the top up here because it's opposite 30 degrees. It's going to be our 1/2. So that means our coordinate down here that we're going to use for sine, cosine, and then eventually for tangent, it's going to have an x, and that x is going to be positive because we're counting to the right. That's 1/2. And then we're going down on the y as negative, so that thing's going to gain a negative root 3 over 2. So we want to know the answers. We want sine of 300, cosine of 300, and then tangent of 300. All right, sine and cosine are easy because they are x and y. So I did list them the other direction. This is how you're going to see it more commonly. People put sine on top first. Sine is the y. So that's going to be our negative root 3 over 2. Cosine is the x. That's going to be our positive 1/2. Now remember, we need to divide these things for tangent. So we're going to do this down here on the bottom, see what happens. Negative root 3 over 2 divided by 1/2. So this one we actually need to keep it, change it, flip it, and see what happens. We change that to multiplication, that's 2 over 1. That cancels. So we get negative root 3 over 1, which is just negative root 3. So tangent is just negative square root 3. That's all there is to it. That's what we're looking for. See you soon.